Hello everyone. In this question, it is said that if A be a matrix cos theta 0 minus sin theta 0 1 0 and sin theta 0 cos theta, and for some theta which belongs in the open interval 0 to pi, we have A square equal to A transpose, then we have to find the trace of the matrix A plus I whole cube plus A minus I whole cube minus 6A. Okay, so first of all, let us try to simplify this expression. Okay, so we are given this A plus I whole cube plus A minus I whole cube minus 6A. All right, so this is A plus B whole cube. If I try to expand using x plus y whole cube or A plus B whole cube, this I will get A cube plus 3 times this square of first term, A square times I, which is A square, plus 3A times I square, which is I, which means this is 3A only, and this I cube will be I, right? Because if you square or cube the identity matrix, you get back the identity matrix back only. So this is the first expansion of this first term. Okay, then in the second term it is A minus I whole cube. So we have A cube and the sign will alternate between plus and minus, right? So A cube minus 3A square plus 3A minus I, and then minus 6A. Okay, so on simplifying, we see that this 3A square and this 3A square will cancel, and this plus I and this minus I will cancel. Okay, so we are left with 2A cube. This 3A square will cancel and this I will cancel. Okay, we are left with this A cube plus A cube is 2A cube plus 3A will give me 6A plus 6A minus 6A. So this reduces to 2A cube. Okay, so when we have to find the trace of this, we have to find the trace of this 2A cube. Okay, these are the same, exact same matrix. So now the matrix A is cos theta 0 minus sin theta and 0 1 0, and in the third row it is sin theta 0 cos theta. Okay, so a general trend is that if the matrix usually have thetas in them, chances are that these are rotational matrices and these are usually orthogonal. Okay, so let me try to check if it is orthogonal or not. So if this is A transpose will be the matrix in which the rows and columns are shifted, right? So the first row will be this first column, right? So this is cos theta 0 sin theta. Then this second column will be the second row here, 0 1 0, and this third column will be the third row here. So this is minus sin theta 0 cos theta. Okay, so now let me check if it is orthogonal or not. So I will multiply A and A transpose. So this will give me cos theta times cos theta is cos square theta, right? Cos square theta plus cos theta times 0 is 0. Oh, sorry, the first element is cos theta times cos theta, so cos square theta. Then 0 times 0 is 0. Then minus sin theta times minus sin theta is plus sin square theta. Okay, so this is the first element, sin square theta. Then this is cos theta times 0 is 0. 0 times 1 is 0. Minus sin theta times 0 is 0. Okay, so this is the second element. Then this is cos theta sin theta. So third element is sin theta cos theta. 0 times 0 is 0, and this is minus sin theta cos theta. So this will cancel out. And then the second row, first element of the second row is 0 times cos theta is 0. Then 1 times 0 is 0. And 0 times minus sin theta is 0 again. Then second row, second element, 0 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. So we are left with 1. And then third element is 0 times sin theta is 0. 1 times 0 is 0. 0 times cos theta is again 0. And last row, sin theta times cos theta is sin theta cos theta. Then 0 times 0 is 0, and this is cos theta minus sin theta. So again, this will cancel out, sin theta cos theta. Okay. Then second element of third row is sin theta times 0 is 0. 0 times 1 is 0. Cos theta times 0 is 0 again. And this is sin square theta, sin theta times sin theta, sin square theta. Then 0 times 0 is 0, and cos theta times cos theta is plus cos square theta. Okay, so this is the final answer of this AA transpose. So this reduces to this cos square theta plus sin square theta is 1, 0, and this will cancel out, right? Sin theta minus sin theta cos theta minus sin theta cos theta. This will cancel each other. So this becomes 0. Second row is 0, 1, 0. And this sin theta cos theta will again cancel each other. So this becomes 0, 0. And this sin square theta plus cos square theta will become 1, right? So this becomes the identity matrix, 3 by 3 identity matrix, right? So this A is orthogonal. So therefore, A is orthogonal. Orthogonal matrix, right? So we are given that A square equal to A transpose. Okay. So now we have to find the trace of this matrix, and this matrix is nothing but 2A cube. Okay. So we have to find the trace of 2A cube. So let me try to find out A cube. So A cube is nothing but A times A square, right? And we are given that this A square equal to A transpose for some theta, right? A square equal to A transpose. So this becomes A times A transpose, right? And since A is orthogonal, A transpose is I, right? A is orthogonal implies A transpose is I, right? So this becomes I. Okay. Therefore, 2A cube will be 2I, right? So this is nothing but this matrix 2, 0, 0, 0, 2, 0, and 0, 0, 2. Okay. So we have to find the trace of this 2A cube, right? So this is very easy. The trace is the sum of principal diagonal elements, right? So trace of 2A cube is equal to trace of 2I. Okay, so this is sum of the principal diagonal elements. So this is nothing but 2 plus 2 plus 2. So this is 6. Okay, so this is the final answer. I think this was a numerical answer question. So you have to type the number in the exam. Okay, so this is it. The answer is 6. Okay, thank you.